So we will be looking at this question number 20, that is from the correlation coefficient. But before doing that, let's look at the covariance and the correlations, their definitions and their properties. So how we define the covariance between two random variable, right? And what covariance tells you, or what covariance will give you, is the information about the dependency of the two random variable, that is x and y, right? So how we define this covariance between two random variable, between these two x and y, is that you take the deviation of random variable x from its mean, and take the deviation of random variable of y from its mean, and take the product of these two and find the expected value of that. Then that will give you the covariance, right? So what we are asking is whether two deviation tends to have the same sign, or whether whether they move in the same direction or not. So let's not worry about that thing. Look at the definition. How we define this covariance is like this, right? And now let's suppose that you have the two random variable, that is x and y. These are independent. Then in this case, the covariance will be 0, right? So if we have two random variable, that is x and y, are independent, right? Then if we have the expectation of x and y, then we can write it as expectation of x into expectation of y, right? So similar thing, we can write this expectation to individual expectation, right? And we are saying that the two random variables are independent, then their covariance will be 0. That is the one thing. And the very important thing is that if we have two random variables that is independent, then we can sure that the covariance will be 0. But if you are calculating the covariance and you have no info about that two random variable is independent or not, but you calculated the covariance and you found that the covariance is 0, then you cannot comment about their independence, right? So independent will guarantee you that the covariance is 0, but covariance 0 doesn't guarantee you that the two random variable will be independent. Let me just give you an example. Suppose you have this x and this y, two random variable, and you see that, and these are the points x and y, right? So you have x, that is 1 0, you have x minus 1 0, and 0 1, and 0 minus 1. These are the points, right? So if you find the x, so if you try to find the the covariance, right, for that you will have to calculate this product term, and you see that all these product terms are 0, right? So ultimately you will find that the covariance is going to be 0. But you see that these two random variables, that x and y, are not independent, they are dependent. If you have given this info about x, that is equals to 1, then you can tell about that y is going to be 0, right? If you have given this info about x is equals to minus 1, then you can tell. So in this case you see that x and y are dependent, but their covariance is 0, right? So that is what independence of two random variables will guarantee you the covariance is going to be 0. But if you found that the covariance is 0, it doesn't guarantee you that two random variables are going to be the independent, right? So let's look at the few properties of this covariance. So if you are taking the covariance between the same random variable, that will lead you, and that will give you the variance of x, right? So you can put this into this formula, and you will find that that will give you here you can put. So basically that these two term will be same, right? So that will you will get the square of it, and now if you expand, then ultimately you will going to get this, what that is the variance, right? And again you can find the covariance between two random variable, that is going to be the expectation of this product minus the individual expectation, product of the individual expectation. How you can find this? Again, you can put this into the same into this formula, right? And now you will do the algebraic multiplication here, and ultimately you will find that this is what you are going to get. So this is the important result, right, that you can use it while solving the problem. And again, if we want to find the covariance between a random variable, that is the linear combination of some constant, and between this y, so again you can use this formula, right, to expand this. So here you can assume this as one random variable, and this is the second, and you can use like, so x is here this complete thing, and y is here y, right? So this is the product between these two, and their individual expectation, right? And if the if in the question, if it is given that the mean of this y is 0, then this whole term is going to be 0, right? And this one, so basically this whole term will be 0, this will be 0, right? So ultimately, if let's suppose that you have given the mean of this x and y is 0, then this whole term is going to be 0, and this will be 0. So what you will get is 8 times, and this is nothing but the covariance of x and y, where x and y, you can say the mean of the x and y is 0, or right. So similarly, you can find the covariance of x, or the sum of these two random variables. So you can treat it as x and y, and you can simply put this in formula, and accordingly uh, if whatever the given in the question, maybe in the question you will given that the mean of this x is 0, so according to that you can expand and you can calculate, right? The main point is that you use this formula to expand, then according to question, if it is given that the expectation is of x is 0, then this whole term will be 0. So you can use it and you can explore these, right? Now there is one more thing, that if two random variable, uh, in general, if we want to find that the variance of the sum of the two random variable, right, and we have not given that these two are independent or dependent. So in general, if you want to find, so this is how you are going to find the variance. So variance is nothing but the expectation of your random variable, the expectation of your square of your random variable minus the mean square of your random variable, right? So this is, now you can further uh, expand this, and ultimately you will find that this is nothing but the variance of the sum of the random variable is variance of x plus variance of x1 plus variance of x2. So that is nothing but the sigma x1 square plus sigma x2 square plus 2 times the covariance of x1 into x2. And if you have given that in the question that this x1 and x2 is the independent, then what we can do, we can we know that the covariance is going to be 0, then it will be simply the sum of the variance of these two, x1 and x2, right? Now here comes the correlation coefficient, right? So So what you do in the correlation coefficient is simply normalize the covariance. And how you are going to normalize the covariance? Just divide by sigma x or sigma y, and this sigma x and sigma y is nothing but the standard deviation, right? So right, so and the correlation coefficient will have no you can say unit, right? So because that if this one is will have the unit meter and this one is a meter, then that will get cancelled. So ultimate point is that this correlation coefficient have no unit. And how you are going to get the correlation coefficient? Just by normalizing the covariance. And how you are going to normalize it? Just by dividing the standard deviation, that is sigma x into sigma y, right? And this is nothing, this upper term is your the expectation of the whole thing is the covariance between x and y, and this covariance will lie between -1 to 1, right? And again the same thing, if two random variable that is x and y is independent, then that will guarantee you that it is going the correlation coefficient is going to be 0, and you can also call it that is uncorrelated, right? If two random variable is independent, then you are guaranteed that the correlation coefficient is going to be the 0, or you can call it uncorrelated. And converse is not true again, right? If you are finding, if you do not have the info about the independence of x and y, but if you are finding the correlation coefficient and you found that you got the correlation coefficient 0, then you cannot comment on the uh, independence of the x and y, right? Again, if you find the correlation coefficient between same random variable, right, so that is going to be 1, right? Because how? So that will be nothing but the covariance of x into x divided by sigma x square, and this is nothing, you have already seen that the covariance of this is nothing but the variance, right? So that is going to be anyhow the variance, and variance is nothing but the sigma x square, and that will get cancelled, right? And that will give you 1, right? Okay, now let's first look at this first example that you have given in the sample paper. So I have already solved it to save the time, so that okay, so the point is that you have given this x and y, and you have to find the correlation coefficient between x and y. So correlation coefficient is nothing but this is how we define the correlation coefficient. What we do is the normalize the covariance, and how we normalize is by dividing the sigma x and sigma y. Now here, to calculate this thing, you will have to calculate. So how I have calculated is that you can again define the covariance as the expectation of the product of x random variable x and y minus product of the individual expectation, right? So for that you will have to calculate this term, this term, this one, and this one, right? And how we can find the standard deviation sigma s? That is going to be the root over of the variance, right? And how we define the variance? That is the expectation of your x square minus the expectation of your square of the mean, right? So anyhow you will have to calculate what terms, the expectation of this, expectation of x, expectation of y. So expectation of x is nothing but the sum of these and divided by the total number of x's. So 1 2 3 4 5. So sum of these divided by total, that will give you the expectation of x. Similarly, expectation of y, sum of these divided by the total y's, that is 1 2 3 4 5, that will give you the expectation of y. And to find the expectation of x into y, first you will have to calculate the x into y. So from here you can calculate the x into y, right? And you can take the average, that will give you the expectation. For similarly you can do for the y square, x square, y square, right? So and now to find the standard deviation, what you will have to find the expectation of x square, that you have already found, minus the uh, mean square, right? Mean square of x. So mean square x that you can find. So that will give you the standard deviation of x. Similarly, you can find the standard deviation of y, and you can put everything in this formula, right? So that will give you the answer, that is 0 minus 0.5. So A is the correct answer for this one. Now let's look at one more question based on this covariance and correlation. So let's assume that you have given these two random variable, right? That is x and y, and the mean of the random variable is 1 and the mean of the random variable y is 2. So these two are the mean of x and y, and their variance is given. The variance of random variable x is 4 and variance of the random variable y is 1. And also we have given this correlation coefficient, that is, so how we define the correlation coefficient is what we do, we normalize the covariance, right? And how we normalize is by dividing the standard deviation of product of the standard deviation of x and y. So from here, how what we can say that the covariance is going to be 0.4. So this is given 0.4 into sigma x is root square of this, so square root of 4, this 2, and square root of 1 is 1, so that will give you 0.8. So from here you see the covariance is nothing but the 0.8. Right, so what we have to find is the correlation coefficient between now okay, so let me complete the question. Now we have given the two new random variable, that is w and y, and how w and y is connected to x and y, that relation is given, right? So that v is equal to minus x plus 2y, and this w random variable is defined as x plus 3y. Now what we have to find is the correlation coefficient, that is rho vw, right? So we have to find the correlation coefficient of the random variable v and w, right? So how we can write the correlation coefficient of v, and here here it will be v and w. So that will be the covariance of v w normalized by that the standard deviation of v and standard deviation of w. And how we define the covariance between v and w is this, right? The expectation of the product and minus the expectation of individual random variable, right? So again, what you have to find is that these terms, right? So these terms you will have to find, and right, and and also you will have to also find the that the standard deviation of this v and w, right? So you can go through that, right? So to find the expected value of this product, you will simply put this, right, and you will simply multiply this, and right, and you will take, since expectation is linear operation, so you can take the expectation of individual one, right? So ultimately you are going to get this. Similarly, you can find the expectation of v and w, and how you are going to do that same way. So you will put v here and expectation of w here. Now you will take the expectation of individual one, and at the end you are going to multiply, right? So you are going to get this, right? Now to find this, you are going to put this term and you are going to take the difference with this term, right? So the main point is here, after doing all these algebraic calculation, the main point is that you will find here that these two terms will give you that the sigma x square, these two terms will give you that sigma x square, and these two terms will give you sigma y square, so sigma y square, and we are left with these two terms. So if you look, this green one, so these green one are nothing but the covariance, right? So minus times of covariance, so that if you see, that is nothing but the green one is nothing but the expected value of xy minus expected value of x into expected value of y, right? And from where we are going to get this value? So this yellow one is already given, right, in form of the sigma x square, and this pink one is already given in form of sigma y square, and this green one, right? So this green one we have find from here, right? From this correlation coefficient we can find the covariance of this xy, so that is 0.8. So after you put all this value, that is 4, 6 and minus 8, so this numerator term you are going to get is the 1.8. And how you can find the standard deviation of v and w, by using the same definition of the standard variance. So how you can do that, the you can use the definition of this variance, that is the expected value of v square minus the mean expectation of mean ka whole square, right? And further you are going to expand this and you will find, so so it is easy, right? You ultimately you will find that this is nothing but these two term will form you the sigma x square, and these two term will give you sigma y square, and again you will have this expectation of xy into this expectation of xy, that will give you the covariance. So from again you can use this covariance to find, and again you will take the square root of this, you will get the standard deviation of v. Similarly you can find the standard deviation of w, right? And at the end you can find the correlation coefficient by uh, 1.2 and the product of these two, right? So that will give you 0.1298. So you can go through that. So so the main point is that I have solved it, but the thing is that uh, I have given you the process, you practice it, uh, because ultimately you will have to solve, right? Even if I am solving, that is not going to give you the any kind of benefit, right? So I have given the procedures, and that is all about this correlation and covariance. Thank you.